Alright, so we're going to continue with slope. I think that I've taken care of my wayward hand issue in making new pages and all that, but who knows, we'll see what happens. Slope, so in the last video we talked about the graphical and we kind of bridged to the tabular idea. So here we want to use the tabular language. And so you may have a table of values, you know, x and y values. Now they may not say x and y, they may say all kinds of different labels. Here, you know, so suppose we've got 1, 2, 3, 4, and here we've got 7, 9, 11, 13, something like that. Then in this case, you know, if I want to get the slope, I do indeed go to that idea that, oh, the slope is just, I'll take some y2 minus y1 over some x2 minus x1. And so suppose I go here and I just say, well, let's let y2 equal 9, y1 equals 7. Let's try that again, 7. X2 is equal to 2 then, and x1 is equal to 1. And in this case, if I plug everything in, I get m equals 9 minus 7 over 2 minus 1. So I get 2 over 1, but that's just 2. Again, get that out of there. Not sure what I just did there either, but hey, you know, one of these days I'll maybe figure it out. So here we have, you know, a slope of 2. Now in this case, I chose to make sure that my points all had the same slope. So if I scroll down just a little bit and I say, well, what if we had tried like the 13, the 4, 13 and the 9, 2? Well, then in that case, well, m is equal to 13 minus 9, because there's my y2, y1, over x2, so that would be the 4 corresponds with the 13, and 2 corresponds with a 9, and in this case we get 4 over 2. Well, that's different looking than 2 over 1, but in terms of fractions it's exactly the same thing. That's 4 divided by 2, which is 2. So we get the same answer, and if we tried any combination of those we would get the same answer every single time. And then we'll do one more thing. We'll use that 9 and 13 again. What if I had just arbitrarily decided to go the other way? This is the nice thing about the formula, is negatives will take care of themselves. So notice I can tell I'm doing the formula right, because the important thing here is that the 4 and the 13 are above and below each other. 4 and 13 go together. The 9 and the 2 are above and below each other, and the 9 and the 2 go together. So if I had actually switched that around and done 9 minus 13 over 2 minus 4, the lovely arithmetic and mathematics works out wonderfully here. I get a minus 4 and a minus 2, but a negative divided by a negative is a positive, and so that's the same thing as 4 divided by 2, which is just 2. So I get that same answer again. And that's the idea of doing this tabularly. Now you can run into some issues though. Suppose, and now I'm going to, well, let's see, before I run into those issues, let's look at this. Just for the heck of it, suppose I had y and x, and here I had maybe 2, 4, 6, and here I had maybe 8, 16 and 24. Now, if I ask for slope, you know, there's a good question there, because even though the names are x and y, it may mean that I put the y first in the first column because that's the thing that goes on the x-axis, and I put the x in the second column because that's the thing that goes on the y-axis. Now, why I would ever do that, I don't know. But, let's just change the names to you know, something like years and something with X in it, foxes. Okay, so in that case, well, yeah, it might make sense that I don't know what this has to do with foxes, but these are the number of years, 8, 16 years, 24 years, and then the number of foxes. You know, so it could be something like that, where sure, I could talk about putting foxes on the number of foxes with the y-axis and the number of years with the x-axis. That would make sense. Usually the x-axis is the independent thing, and time is pretty independent. It just keeps on going without us being able to do much about it. I'm coming back here. Somehow I made all of a sudden 4 pages. Don't know how I did that, but we'll come back down here. And so here we have the you know, that you may have the x and y switch, but you still want them as x and y. Or you may have the x and y switched and you don't want them to stay as what we usually think of as x and what we usually think of as y. You know, we actually really do want this first column to be the independent variable, the x-axis, and the second column to be the y-axis. So how do we handle something like that? And, well, when you want slope, you really need to know more specifically. You want slope is the rate of change of the dependent, I'm having trouble with my penmanship, dependent variable with respect to the independent variable. Okay, typically, so usually or typically, x is independent and y is dependent. So typically, when we're talking about slope, we're talking about the rate of change of y, rate of change of y with respect to x. Now, but again, you have to think of that in Cartesian coordinates. So it's the vertical, you know, the y is the vertical direction and the x is the horizontal direction. Okay? And so here, back here, if we really just did have an x and a y, and somebody said, what's the slope? You really need more information than that. You need to know which is the independent and which is the dependent, and so, you know, they may say, well, what's the rate of change of y with respect to x? And And so now that tells me that, oh yeah, the x really is the x variable, and the y really is the y variable. And so what I might do is I might first rewrite these this way, just so I don't get confused again later. And those were 2, 4, 6, 8, 16, and 24. And so now when I want that slope, I'll get that rate of change. Again, I made these so no matter which ones I do, I'll get the same answer. So let's do the 16 minus 8 over now 16, that went with x equal 4, and the 8 went with x equal 2, and so I get 8 over 2, or I get a slope of 4 in this case. So that's tabularly for the easier cases. Now I'll stop this video and we will start a new one on a little more complex tabular information.